Which?
Oh yeah, from last Wednesday. So Pete makes these long loops, which are really useful for looking at stuff in the past. And last Friday, we hadn't had enough time to put anything together for that storm that came on Wednesday, the record snow. And it struck me as a really interesting event because it developed on a little wrinkle in the flow. And I think it was over Iowa or something, came right across us. The heavy band was right over us.
This is sort of the beginnings of it over here.
Yeah.
This is April 17th. This is sort of the beginnings of it coming through here.
Yeah, so there's this feature. That doesn't have much to do with what migrated to the north, but here's the circulation. It's really interesting. One wave after another of these bands that just kind of went right over us, and of course dropped the 7 inches of snow. So a really interesting event. And I remember at the time thinking, just taking a little bit of time to be able to look at some of the most basic dynamical picture of it, and it was an intriguing event. So I got it written down. I want to do a full scale analysis of the various forcings for vertical motion, both from the QG perspective, but also from the kind of basic state variable perspective, and see if we don't learn something from these things. Because it's nice and isolated. It's not connected to any other structures that might contaminate the signal. At least that's how it struck me when I first looked at it.
I'm going to flip to a water vapor.
Yeah, okay.
It's even black and white for you, John.
Yeah, thanks. I like the
So this is the beginning of the storm.
But this was our Sunday storm that had given us 2 or 3 inches of snow, right. And so this thing had turned into a major circulation feature. This is what we got going on over us today, as it turns out, something quite like this, but further to the west. We'll talk about that in some detail with the current observations. So I don't remember the context from which this little bit of a wave kind of came out of, but it was a pretty strongly frontogenetic feature over much of its lifetime. So there it is. Look how isolated it is. And one gets the idea that things are just developing and blossoming as they move forward. And there's finally the circulation that emerges at probably at about 500 millibars. So really an interesting little event. And we were perfectly positioned to squeeze the maximum amount of snowfall out of that thing. And then chilly the day after, as we all remember. But not by the next Friday. And look at all these little wrinkles and little roll-ups that go on. This is why I like the black and white. Here's another one coming. Just one after another on the backside of that broad upper trough. It's just an absolutely beautiful roll-up picture. Here's a couple more that are about to go. Isn't that nice?
It's getting smaller and smaller.
Yeah, they do. They keep getting smaller in scale. Just fascinating what was going on there in that northerly flow. So, and nicely resolved, the data. And this was then, what was this? This was the thing.
This was the little cutoff that kind of went through southern Illinois.
Yeah, I missed us to the south.
Yeah,
we didn't
really
get anything out of this. Okay, so that was a pretty interesting week, as we know, and again, it's only a little bit more detailed than what we were able to do before. The semester just is unrelenting. Maybe in the summertime, put some things together on it. Let's take a look at. Oh yeah, do you have a good movie of the snow melt?
I think this is it.
Oh, look at that! That's great.
That's the visible the next day.
And you can tell where the gradient of heavier snow was. I mean, it just disappears where there was only an inch on the ground, and it just can't get past about this line where it was heavier than that.
It was
Isn't
so
that
close
dramatic?
to us. This is just south of us.
That is so dramatic. Yeah, what a great movie. Don't ever get rid of that. We need to have that. That's so interesting. I only had about 3 hours of that. I showed it to my class on one of the days. It wasn't quite as good as this. This is much better. We had a short period of it. It's great. And that was, I think, one of the more interesting things about that event. Not only that we got that much snow, we set the all-time minimum high temperature for the day on April, what was it, 20th? I guess it was 19th. 19th. 33, I think, was the high. That's the lowest it's ever been on that day for a high temperature. And then to see it snow for so long throughout the day with the sun being up, it wasn't really dark till 8 o'clock, so you could see snow at night, which almost never happens around here. And then the rapid melt the next day and Friday afterwards, it just about completely disappeared down here in Dane County on Friday. So pretty amazing. What a week. And then just walking around this Wednesday when we had a nice day, was that the day we got to 72? Or?
I think so, yeah.
Yeah, and it was only a week after being stuck at 33 with heavy snow. So that was a pretty fun, good thing, a bunch of good things. Let's take a look at our current satellite. We good?
Did you say last week it wasn't going to get above 60?
I did. Yeah, I was surprised by the 72. I really was. And I was hoping we wouldn't get above 60 until Monday to tie the record. And we did it on Saturday or Sunday. Sunday was 62, so we lost by 1 day.
That seems to happen a lot. The predictions a lot of times fail this time of year because somehow we just don't recognize how powerful the sun is.
I think there's a lot of truth to that. And I'll say there's a other side of that coin. The first cold snap routinely the temperatures are dropped way below zero. It's going to get down to -10. And even at the airport, maybe it gets down to 1 above zero on the first cold. So a 10-degree forecast bust is not at all unusual. And, the first time you enter the next season. And you're right. I was thrilled to get 72, but surprised by it. And we missed the latest 60 of all time. Although Jordan told me the longest gap between days that were 60 degrees or higher was 181 days, and I forget the year now, I have it in an email. We were only at 130 days this year, so it was nothing. As much as we complained about it, it was nothing. So we didn't get close to that. So a pretty interesting day across the eastern part of the continental United States. So first, there's a complex that's, I think, finally starting to get itself organized, but even in the process of getting organized, spreading pretty substantial, moderate, some places heavy rains over the northeastern U.S. from everywhere across Pennsylvania, New Jersey, New York, and into New England. And then secondarily, this really interesting flow feature that's coming straight from the north. We'll see this maybe in a couple of other depictions. Perhaps the water vapor will be good. And the clouds associated with it. Though it looks complicated in almost every way that you look at it, there is an underlying, very simple explanation, it seems to me, for where the clouds are coming from and the likelihood of their sustenance. So I'll comment about that as we get into that. So that's going to be the feature of the day for me. I spent a little time this morning thinking about it. But broadly, the rest of the country is absolutely beautiful. Almost no clouds anywhere, all the way from the Mississippi to the coast of Washington and Oregon. And you can see the high elevation snows in Colorado, parts of Wyoming, Montana, and Idaho. Really, obviously, it's just absolutely beautiful. And then some clouds coming on shore of the Pacific Northwest. But as I say, other than that, the country is enjoying a really nice weather day today.
I think all the ski areas closed.
Oh, is that right in Colorado?
Colorado, except for maybe the 8 days behind.
Okay. So this is all snow above about 7,000 or so feet, probably, something like that?
Well, there's still snow up there. They just close them at some point because it's not coming.
Okay. And there's a lot of melting probably going on the lowest fringes of them today too, so maybe they're glad they did that. Okay, let's take a look at the radar before we go to the West Coast. So here's what's interesting around the country. Slide over the east a little bit, Pete. So you can see this broad region of moderate, probably sometimes speckled with maybe heavy shower coming all the way through eastern Pennsylvania, New Jersey, New York, parts of New England. So the rain is spreading to the north with this system. And so we'll want to see what that's connected to in the middle and upper levels. Then there's a little bit of convective activity over the Keys and far southwestern Florida that's interesting. Almost nothing else over the Gulf. A little bit of a rain band across Michigan into western Ohio and central Indiana. It's possible that it's raining on the southern end of here and maybe not really doing anything in the northern end in some of these locations simply because the air is so dry. The dew points are in the 40s here, I think we'll see, and then low 30s to the north. And we're in low 30 dew points here. So we had a band go right by us I didn't feel any drop of rain. I didn't hear anybody report that such a thing had happened. And then some heavier convective activity right over to the south of the arrowhead, I should say. And you're going to see that's precisely where one might expect that to be the case. That's the strongest region of PVA by the thermal wind. And then it's all in sort of a linear line. And you can see that manifest on the radar. And then further to the west, I think you'll see just a little bit of precipitation making landfall over the coast of, part of circulation. It's actually coming across the southwestern part of Oregon and then along the coast of Washington from mid-coast Oregon all the way up to about Olympia in Washington State. Okay, so let's take a look at the surface map too, if we could now, Pete. And first in our region, 52 over 29. So though it was precipitating in a band in the radar at mid-levels clearly over us, this dew point depression is so big that it's just hard to get any of that precipitation to hit the ground. And it's true generally south of us. The dew point depressions are on the order of 30-ish degrees. Just to our north, of course, the column is closer to saturated in some of the places where it's been raining this morning. 34 over 34 at, I don't know where that is, Rhinelander, 40 over 35 in Wausau. So pretty nice evidence that it is the dry air on the southern end of this thing that's really kept us from precipitating.
Right, John, another interesting aspect is you can see also in the radar that we're just looking at, you saw this nice setup of precipitation that was oriented in this linear fashion.
Yeah.
You might think, oh, that might be a front. In fact, it shows up really nicely in the surface observations in southeastern Minnesota and eastern Iowa, you can see the southwesterly
Oh,
winds
yeah,
or
right.
even southeasterly winds, and they turn cyclonically across that boundary as you
Yeah.
move into central.
They were all
Wisconsin.
northeasterly from
Yeah.
Chicago all the way up to the northern part of the state. Yeah, that's right. That's right. Very interesting.
Right through there. Yep.
Really interesting. And very dry air on the southwest side, which is kind of why we're dry. We've been in that kind of history. Yeah, it's a good point. And then over to the east, several places with moderate rain. There's moderate rain near the Hall of Fame. There's light rain in Albany. Moderate rain near Hartford, north of Hartford. So this is all the precipitation we saw on the radar that's at least light to moderate, as we could have intuited by looking at the reflectivities. Let's see what it looks like down in Florida, if there's anything actually coming across. Precipitation, light rain in Miami with a 78 over 70. That's a beautiful day. It's like living in a terrarium. And then let's keep going off to the west. I think we saw it's nothing in the rest of the country, and then Pacific Northwest was interesting, perhaps, with some nobody reported moderate rain here. Is that Medford, Oregon? Moderate rain in Medford, and then fog and light rain probably along the coast and near Bellingham, but not anywhere else that we saw north of about Olympia. So, okay, couple of things I want to do first. Before we leave the continental U.S., let's look at the water vapor over the continental United States. And try and see if there's any obvious structure in that northerly flow, because I haven't shown you the upper level chart yet, but that's what's going to be of some interest when we take a look at the origin of this disturbance that's coming across us. It's not really very deep or obvious dark band in the water vapor imagery here, but there's something coming through central Manitoba into Minnesota, and we'll see some more evidence of what that something is in just a minute. This is a pretty intense little cyclone coming off of Newfoundland toward Greenland. And what day is it today? Friday. I don't remember where this thing came from, so I don't think we ever dealt with that one this week. And then the next one in line is the one we were just talking about in the eastern U.S. And then off the coast of California, and there's an obvious upper circulation. We'll get off to the west coast in just a minute, and it's on the northern fringe of that, where the clouds and at least fog along the coast, and maybe some moderate rain in Medford, right there with that shower. It's just been reported. And if you can see, there's a little line, a shear line here in the water vapor that curls up over the prairie provinces. Really nice right there. I wish we had a better view of it.
I'm curious if that shows up better in the color version.
A little bit better.
Features
Maybe.
show up better.
It might be a little bit better. There's like a string of pearls here coming across in that shear line. Really nice. And even this feature in the northerly flow is a little bit more obvious. It's not always the case. Sometimes it doesn't look so good. Okay.
West Coast?
Yeah, West Coast, and then we'll go and look at the upper level charts. So here's the West Coast infrared. Difficult to see the circulation in the infrared, non-water vapor infrared. Here, you can see the clouds obviously connected to some sort of cyclonic circulation across Oregon, and then off the coast of Vancouver Island. Here's another intense disturbance that's getting itself organized. This thing looks like it's going to be stationary for a couple of days, actually, just north of Hawaii. And you can see that it's an excursion poleward of some pretty cold air. So we've got instability showers and clouds. There's the showers, maybe. These are the clouds. Heading towards, you're at least at 30 degrees north here, or maybe lower than that, because Hawaii is 25. So something on the order of 30 to 32 degrees north. So this is definitely cold air headed equatorward into the subtropics. And down sheer of the upper vorticity maxima, there's a nice cloud head developing. And as I say, I think that thing is going to remain somewhat stationary in that location over the next couple of days. That's what it appeared in the forecast. And then over the southern part of the Bering Sea, a really monster cyclone kind of wrapping itself up, wrapping its life cycle up over this part of the world. And then you can see the stream from the southwest farther to the west associated with that.
Really weird after looking at the so much GOES 16 imagery. This looks like an old home movie or something.
Yeah, you almost need to have that sound effect, from the 8mm machine.
Yeah, right.
Okay, let's take a look at, that's good. Glad you did that. So here's, in the water vapor, it's more obvious where the circulation center is. And it's not, one single circulation center. It's kind of a broad, elongated trough. And then this feature here to the north of Hawaii, it looks more obvious too. Very, very deep tropopause trench, most likely associated with this migration poleward the equator, I keep saying polar, the equator of this upper trough. And then the coldest there, right in the middle there, that's all convective shower activity. Okay, let's take a look at the 500 milliwatt chart. And of course, we'll do the super. And so here's the interesting setup for our disturbance over us that we're going to contend with today and tonight. And that is pretty strong northerly flow all the way from one of the Great Lakes, the Great Slave Lake, I think, in the Yukon Territory, straight over Lake Winnipeg. It doesn't really change direction until you get down into the Indianapolis area. So it's pretty straight northwesterly flow. Little bit of an embedded shortwave trough right over Lake of the Woods at 12Z this morning. You can see the wind's really 25 knots. That's a strong enough wind to believe that there's really some larger disturbance in that flow than was evident here. But in any event, if there's not only cyclonic shear in a line along this flow, but then there's this embedded little shortwave. So one imagines there might be sort of a bulbous head to an otherwise tadpole-shaped region of vorticity at 500 millibars. We'll take a look at that in just a minute. Were that the case, down shear that would be right over the northwest part of our state, which is where we see those convective elements in the last few hours in the radar. So I think there's a nice relationship between the structure at upper levels and what's going to be the case down here over the arrowhead into the southeast of it. So we'll go back and take a look at some of that. I'll note, though, before we do, there's very little cold advection along this, so it's not really a developing upper front. There's considerable spots where there's warm advection, not only here in western North Dakota, but across north-central Minnesota, maybe even over the Lake of the Woods. So at the end of this linear shear vorticity strip, which is characterized, if you had to, on average, you'd probably characterize it by warm air advection along its length. It's not a particularly developing upper front, but it is one that's probably characterized by a reasonable amount of gentle and in some places more than gentle updraft. And I think that's kind of accounting for some of the cloud and precipitation that's associated with it. The really cold polar air is far to the north, and it's still there though. It's still minus 40 at 500 millibars over the eastern archipelago. And so it's still, it's possible to get cold at some places, even as late as April, but this is really about the end of it. And you can see wide spaces in that high Arctic where it's not that cold. And so, the sun is up and things are modifying. And here's the upper disturbance that's crashing onto the west coast and dragging those clouds off of the continent to the west at the latitude of Oregon. And so that's a couple of the disturbances that are broadly affecting us in the United States. And here's finally one little short wave over the DC area this morning at 12Z, and it's down sheer of that where we had the most well-organized precipitation that's now affecting New England and the states in the northeastern part of the country. So let's go to tropical and take a look at a cross-section sort of right through that feature, and then we'll do some other diagnosis. So this is valid right about now from a 6-hour forecast made this morning. And so by this time, the cyclone center is near La Crosse, and I've drawn a line from central Ontario down to north central New Mexico. And I've drawn it so it's perpendicular to the geopotential height lines that are shaded here at 500 millibars. And I want to see what that structure looks like. So here's what we have. Ice attacks, 100 knot wind at about 300 millibars. There's the polar jet. There's a 75 knot wind, 80 knot wind at about 280 millibars, a little bit further to the south. And then there's this really nice PV pendant. The dashed line is 2 PVU in the coming from the lower stratosphere all the way down to about 800 millibars, down over, I guess this would be probably somewhere over the river or something, so not far from us. So really dry air. It's not dry on this map, but I looked at the relative humidity, very, very dry. And then every 5 degrees Kelvin in green for the potential temperature. So a pretty strong upper front with no obvious connection to what's going on with the ground. There's no surface boundary that's got a strong thermal contrast associated with those isotopes. So a really nice upper front tied to the jet, presumably historically a result of subsidence under the core, but probably not any longer. And so that's the setup. So one imagines that there's a bountiful horizontal shear vorticity in the middle troposphere in and around this region. So what I'd like to do next is take a look at the 500 millibar vorticity map, not from tropical, because they just don't do as good a job as Pete. So let's go back to our regular map, forecast maps, Pete. We'll look at the GFS not northern hemisphere, but 104 grid. And let's look at the 12Z forecast. This is the 12Z run?
12.
Oh, okay, let's not do that. let's do, I already have seen 0Z, so I just want to make sure what I'm saying is consistent with what I looked at. Let's do a 12-hour forecast from 0Z. Okay, so that's great. In fact, it's such a small region, we can look at just the continental US. We don't have to look at the whole continent. I should have said that, sorry about that. So that's the 211 grid, is it, or?
Yeah.
Great, okay, perfect. Yeah, so here's our upper vortex strip associated with this development this morning, and this is a 12-hour forecast. I'm only showing you the forecast because I had a chance to look at this morning.
Where was that cross section on there? So that.
Right about there, I
So
think.
that strip of vorticity is the injection.
Yeah, that's right, that's right, that's right. So this whole thing is the PV injection, just as you said. And the contours of higher values indicate that it's getting further and further depressed the more you get to the higher value. So I'm beginning to be able to interpret a map like this when I know it's a shear line. I interpret it as a sort of 3D contours of how deep does the tropopause penetrate.
You know,
And this is the deepest penetration right in there.
I guess my first impression when I look at that is I think the filamentation, of the vorticity field, when you see these lines, but it's really not filamentation, it's this injection in the thermal.
Yeah, that's right, that's right. And one can go back and understand what drove the subsidence that creates this. It's no longer subsident in this location, doesn't look like it. But what's really cool about this is that there's a complex vorticity field here, but the pieces are large and simple to understand. One of them is the shear piece, and then there's a really sharp edge across which you go from very high to very low value. So there's a region of potential strong PVA. And then right after that, there's of course a little bit of a ridge in the flow. And so the vorticity values, they don't go below zero, but they get small. And then there's this extra trough downstream, and that's just off of this thing is where that precipitation band in the radar came across Michigan.
But that edge around there that you're talking about, that's the upper level front.
Well, it's the edge of the penetration of the upper front. Yeah.
Yeah, so isn't that like a material surface, like that's actually the tropopause intersecting?
Oh, yeah. This is the edge of like a 2 PVU surface in the horizontal.
So it's like a material surface that it doesn't interact with its surroundings. Exactly. I'm not sure what exactly you think about it, but it's like a tropopause.
Yeah, but there's strong, across the edge, there's strong PVA. And especially enhanced because this vorticity here with a little bit of a mini downstream ridge is much lower value. And then there's more PVA across this boundary from low to high, right in this location. And it turns out that coincides perfectly with what you're seeing in some of the forecast variables and then how they manifest themselves on the radar. So let's take a look at how to do this. I'm going to keep the pointer, the hand, right where the maximum vorticity is.
Before we get off of that,
Yeah.
it's also interesting to note that this strip of vorticity is entering a region that is modestly difluent.
Yes.
And so that might give it a chance to roll up a little bit.
Right.
But I'm wondering about the proximity of the downstream feature that goes from Milwaukee into that other strip right there.
Yeah.
The fact that it's so close, does the vorticity advection upstream of it, the positive vorticity advection upstream of it, kind of cancel out in part with the negative vorticity advection behind that leading strip? So we're in a region of net almost zero vorticity advection, maybe slightly weighted toward the upstream feature.
Yeah, it turns out that's a reasonable conclusion. So I had to look at it. I looked at the 500 millibar vertical motion from my partition shear and curvature advection.
Right.
And you find out that the curvature advection produces a broad region of really small but negative ascent, descent. And then the shear produces a little football shape ascent, descent. And then the shear produces a little football shaped region of ascent right here. And that's where everything's going on, it turns out. So you're right, you're exactly right. There's a lot of cancellation that goes on here, but you can see the individual pieces that do the cancel, which is pretty cool. But it's beyond what I'm going to be able to show you. So let me put the hand here and just, let's go to the forecast at the surface at 12 hours. Look at where that precipitation is. And look at where the thickness lines are. So here you get some ascent and the cyclone's developing there. And then notice the orientation. Now I'm going to put the cursor so that it's parallel to the thermal wind up here in northwestern Minnesota. Now let's go back to 500 millibar. And that's enough. Let me go back to the other one again. I'll go to a higher latitude. I'll go into this thickness channel instead. I should have maybe done that. So that's about parallel to that thermal wind. Now let's go back the 500 milliwatt. And it's cutting across from high to low along this whole line, because this thing is tilted at an angle to the orientation of the thermal wind. So all that forecasted precipitation, and we saw it in the radar, is down shear of this, of the shape of this upper level feature. So it's a really great example of PVA, even though it's an unorthodox orientation for all the different features that are contributing. All this precipitation we're seeing in the radar is a function of PVA by the thermal wind, including the piece that went across Michigan. And if you looked at that map, you might say there's no chance we'll be able to make that diagnosis, but you can. It's really easy to do today, not always. So anyway, that's kind of an interesting feature. And the history of this feature is interesting too, but there's no time to talk about it. And I don't have the knowledge. I haven't looked at it. I don't really know what it is. But it has a beautiful upper front structure at this time, as we saw in the cross section. And there's been historical injection of high PV from the lower stratosphere into the troposphere, and now it's wreaking havoc on with light rain, and maybe there's light snow in some of the higher latitudes of the state. It's cold enough. So an interesting weather event, but it won't probably give us too much trouble. So that's what I have. Did you want to say anything?
I'll say a little bit about
Okay.
the forecast. The other side. Thanks, John. So it sets up things nicely for the passage of this upper feature as it comes across our state and then heads to the southeast. We'll start on next to last time for the year with our meteorogram, John's favorite word.
It is.
You can see this is our temperature forecast, the dew-point forecast, as well as precipitation forecast. And you can see that we have a shot at some precipitation later this afternoon, early into the evening, and just up until about midnight or so. Light precipitation. This model is putting out just under 10 to 15 hundredths of an inch of liquid precipitation. Likely all liquid will be well above freezing, but maybe some parts of the state, particularly toward north and east, where it's a little bit heavier and a little bit colder, might actually see some frozen precipitation. But a slightly downward trend in temperatures with a nice beginning and rebound when we get to Sunday. Let's look at the time height section, please. So the time height section, again, time running from right to left. We can see the isotropes are in yellow. You can see the dynamic tropopause is shown here in 1.5 PV view surface, shown here. It dips down to about 400 millibars, almost 500 millibars actually. In blue is minus omega plotted, so this is significant upward vertical motion that's going to be over us by the time you reach 5 or 6 in the evening tonight. And you can also see the relative humidity is increasing as the column gets nearly saturated or max saturated. Our precipitation begins, and this upward vertical motion and being close to saturation continues into the middle part of the evening tonight. And this is the passage of the upper trough. So this is the upper trough initially arriving into our area, then its departure with the subsidence behind it, thinking motion, and then our dynamic tropopause begins to lift as this feature trough moves off to the east. We'll see that in the forecast. So during the day tomorrow, we're expecting it should be a pretty abrupt, very nice upper trough goes by just as we've had this significant upward vertical motion. We're going to have strong northerly flow and dry air coming in. That's going to help clear us out, and we'll get a nice deep, well mixed layer occurring tomorrow to about 800 millibars or so. We're going to take this temperature 285, and we'll well mix that, bring that down to the surface. We're looking at 285 to the surface as well, which would be in the low 50s, I guess, for tomorrow. Experiment. And then Sunday, sort of similar as well, maybe a little bit warmer on Sunday, with winds shifting from northerly to a more southerly direction, more convection begins to take off. You can also see the downward slope of these with time, indicating that subsidence has been occurring and we're beginning to make more infections taken over. All right, so big event, or the biggest event that's going to occur for our area for the next 60 hours or so is the approach of this upper trough. Significant ascent and with sufficient moisture, we'll get some precipitation, likely just liquid precip and clearing as we go to the weekend. So let's now look at an evolution of those features in the forecast. Let's start off with our PV. We can actually click forward because this runs a little bit too quickly. So this is potential vorticity in the layer from 315 to 325. And you can see that low of maximum potential vorticity just to our northeast. By the time we get to 6 hours of forecast, this is the current time period. I would also expect with this PD anomaly, you can also see it in the time height section, our stability stratification is going to get a little bit weaker. There might be even a possibility, and I think you noted this, of some convective showers embedded here in the center of the vortex as opposed off to the east. John had also pointed out some of that shower precipitation area over parts of Oregon, and you can see that very clearly, this nice upper trough, possibly PD anomaly just off the west coast of the United States. And beneath it, it's pretty cold. We saw temperatures of 5 millibars below about minus 25 to minus 27 degrees C. Pretty cold aloft, so this were to move onshore and probably also going to get some convective showers. And then finally to the northeast, that little upper trough we saw at 500 millibars is forecast to be approaching Albany in New York, and with a small PD maximum in eastern New York State at this time. Let's go ahead another 12 hours ahead, so 18 hours of forecast. This level. Upper trough is now moved off to the east. We're in this northwesterly flow. This is going to be by 1 o'clock in the morning. PD beginning to decrease above us, and we'll see also heights beginning to rise as this trough feature moves off to the east. Really nice, clear cutoff forming off the west coast of the United States. While we're at it, I just wanted to back up a bit. Let's back up in time. I recall when I was a grad student, undergraduate student, it seemed like March, maybe early April, were big times for cutoffs to form over the southwestern United States. I don't see that happening as much. I don't recall it happening much this spring.
Yeah, I think you're right about that. I don't think I've seen too much of that this spring either. Yeah.
So I'm wondering in that, I just think sort of classically, maybe it's the types of maps we look at, but I just don't see this happening a lot at all in the last couple of years.
Yeah. That's a good point.
Anecdotally,
I can't disagree with you. Yeah, I can't disagree with you.
Today when we're looking at this, so we don't see them down here. This big ridge, and then a cutoff over the southwest, and the big problem was when would it eject, when it would get kicked out.
Right, yeah, and that was a classic forecast error. I remember that too, yeah. It's interesting.
Just a
I wonder if the subtropical jet's different this last couple of springs in that longitude band, and maybe that's a factor. I don't know.
Another thing I want to note, we'll see this when we look at forecast, is this area of low potential vorticity that emerged. We'll get a loop of this in a moment. And that's indicative of some convection occurring off of this Florida coast. We'll see that associated with disturbance that begins to rapidly progress northward off the east coast of the United States. So let's go ahead, another 12 hours, 30 hours in the forecast. This level, and you can see the PP values over us slowly beginning to decrease to low values of potential vorticity just ahead of that little PD streamer or PD trough that's getting pressed and moves eastward. And finally, that cutoff is beginning to make it onshore over parts of Oregon to the northwest. Jump ahead just a little bit more. Oh, and people, sorry, go back to that for just a second. Also, you can see we're slowly seeing the PD values decrease over us with time, and you can sort of see that this trough flows almost parallel to the isoflex of PV, the ice tells. So it's going to be slow progression eastward as these advections. I mean, winds aren't perfectly parallel, and in fact, we do have strong gradients here, but in general, this is going to move slowly to the east. So go ahead for 42 hours. You can see again that slow progression of trough eastward, and over us, you can see positive or negative vorticity advection from north by the time we get into approach Saturday night into Sunday morning. Of course, this cutoff is moved onshore. So we expect to see when we look at the forecast significant precipitation in the vicinity of this cutoff, and I guess to be more convective in nature.
Yeah, what a miserable weekend for them.
Right.
We're supposed to have an apartment picnic tomorrow.
Yeah.
Tomorrow should be nice. Here,
Yeah.
cool, but it won't.
I think there'll be some cumulus,
Yeah.
fair weather cumulus, so it'll be mostly cloudy in the afternoon, I guess, but not cold.
Do you mean more of a stress?
Yeah.
Like a stress? I think tomorrow will be sunnier than
Oh, yeah?
cloudy.
Well, I hope you're right. I mean, there's a tendency, I mean, the dynamics are certainly not encouraging cloud development, but the cold air aloft might. That's what I
Right.
think.
So I think it'll be cumulus, but not a stratocumulus.
Yeah. Okay, that's probably a better way. I think you're right. I think you'd be right.
Okay, let's go ahead finally to 42 and 12, 54. Okay, and again, this is Sunday early afternoon. We're on the ridge of the central part of the United States, sort of flanked by these two deep troughs, and decent weather going to be over us. I don't think there's much of a risk of any severe weather, but I think probably showery, maybe even some snow showers and accumulated snow in the western part of North America. All right, so let's look at an animation of that just to watch this again.
Yeah, you know, speaking of the lack of severe weather, I guess I read somewhere the other day that we're way behind in tornadoes.
Yeah.
In Oklahoma, Texas, you know, parts of Arkansas, Louisiana, this time of year because of the cold snap we had in April. And this westerly flow that's going to be without any waves in it just gives them a whole nother weekend, end of April, for more.
We're gonna catch up next week.
Is that right?
I think so.
I hope so.
It's going to get warm here next week for sure.
Are you planning on chasing? Right. Okay, we'll maybe talk a little bit more at the end of this, just where you think the big outbreaks are going to be. But I wonder if the fact that we, this season at least, haven't had many of these cutoffs that then get ejected is also associated with the fact you're not getting that nice varying wind profile at low latitudes for severe weather.
And, you know, that place for a trough is a perfect place. It puts the elevated mix layer out over the plains.
Right.
It provides focus for ascent. It does a lot of things at once. And if it's not there, maybe those things have a hard time assembling.
There's been no moisture either.
Yeah.
This cutoff, well, the cutoff, but rest of the system moved to the south last week, had nothing to work with.
Is that right?
Handful of reports, but I think really too organized.
Yeah.
So that looks like it's gonna change.
I think the whole northern hemisphere has had a dearth of tropical blooms since the sun stratospheric warming.
Late February.
Yeah, but it seems to be waking up. It's starting to wake up this week, and I think next week it's all going to go crazy.
So let's take a look at the surface map, and we'll just quickly click through that, and then look at a much broader view of the GFS. So again, here's the 6-hour accumulated precipitation from 12Z this morning. You can see this strip of light precipitation to our northwest, to our north actually, with a sort of bullseye here, which is probably just down sheer of the vorticity maximum that John was referring to earlier. Go ahead, another 18 hours of forecast. There's that big convective blow up that's associated with that increase in PD as you saw at 315 to 325 surface. Over us, again, light precipitation. That says the upper trough is finally just about through our area by 1 a.m. in the morning of tomorrow. And a broad anticyclonic circulation beginning to develop over us with a northerly flow setting up. Geosurface flow to the northeast, but the northerly surface.
Low thicknesses.
Low thicknesses.
I don't think it's cold enough to snow, though, do you?
I think no. And I would say with absolute confidence, I can say this, less than 6 inches. Over the Pacific Northwest, here's the thickness minimum underneath the deep PD anomaly, positive PD anomaly, cyclonic anomaly, and the precipitation on the periphery of it, showery precipitation forming right beneath it, that low stability area, low stratification area. We'll probably see more of that as it moves eastward. Let's go ahead 12 hours again, 30 hours, 1 p.m. tomorrow afternoon. And this is one of the reasons I think it's going to be less likely stratiform clouds and maybe more likely, as John was suggesting, maybe a few cumuliform clouds forming. It'll be chilly aloft, surface is going to warm up, but we have this broad cyclonic or anticyclonic circulation, which is going to favor more subsidence. I think it will help clear us out, as opposed to being under even a modestly cyclonically curved geosurface flow aloft, which would encourage active acid. And tomorrow shouldn't be too bad. Dry, relatively drier over us, just as well. Again, in this region of low PD aloft, we have convection developing out of the Bahamas. But again, for over us, really nice, I think a nice day tomorrow. Let's go ahead another 12 hours to maybe early Sunday morning, 1 a.m. And the high crest right over us. This is probably going to be the colder of our nights this weekend, for the next couple days at least, as we have light winds at the surface, likely very clear skies, can be very clear skies, and light winds will probably radiate well. It'll be a chilly night before we start our warm up on Sunday. So let's go to 50 to 1 in the afternoon on Sunday.
It could be very clear. You can have high dew points and clear skies, and it's not as clear infrared as it is tomorrow. Tomorrow. Oh, okay.
Clear. Am I clear?
Yeah, crystal.
Okay. Stand on this one. Okay. You have this anticyclone that's drifted to the south And then you can see the beginning of the warm convection starting over here. It's not the strongest warm thickness convection, but we're going to begin our warm up at that point. A lot of precipitation over the Pacific Northwest and Southwestern. Yeah, pretty quiet weather over much of the country. Just, 48 hours or so. Let's quit from this. Let's go to the pivotal page and let's look at a. Let's start with say 48 hours Sunday morning. There, 48 hours, sorry. Piece of break. Yeah. They see with the chilly air to that trough, some light snow in Buffalo and approaching the Rochester area, rain showers, that trough moves down. But again, the anticyclone, just as we saw in the MN5 forecast, similar forecast, shifted southward, kind of region following the cold advection to the south. Broad area warm advection setting up. And one of the interesting things we're going to see in this forecast is as this high begins to migrate to the southeastern part of the United States and then offshore, we're going to begin building this subtropical ridge over the southeastern United States. Something to watch, I don't think it's explicitly in the forecast yet, is as this builds to our southeast, over the southeastern United States and the southwestern North Atlantic, you begin to get this return flow around the high, and I think it increases the chances for an extended period of precipitation. I don't know if it's going to be flooding at this point yet. It's going to take a while because the area is relatively dry. It's going to take a while for it to chuck around the anticyclone across the Caribbean and then into the Gulf. That's something to watch as this high moves southeast. Let's go ahead to 72 hours. Okay, so this is Monday morning. Again, this slow-moving cutoff finally gets off to the East Coast, but there's still a little bit of rain and snow in New York State. But we're in nice, fairly strong warm advection as this high settled even further to the southeast, and precipitation breaking out again well to our west ahead of the trough that was moved offshore late tonight or over the weekend. Right. 5:58. This is right over us, and yeah, we'll go ahead just 12 hours. This is Tuesday or Monday night, Monday evening. And the precip sort of dries up. This is, again, this broad anticyclone set up, but this is, all the precip's going to be well more west and north, it appears, with a pretty brisk southwest wind.
Look at that heavy precipitation in northern Ontario. That's all Gulf of Mexico moisture, don't you think?
It probably is, it's so dry, it takes a while for it to lift.
Yeah.
Until it gets into, just south of Hudson Bay. I don't know if this is, if we got the Smallcombs following us on online. If you're there, send me a text. Text about tornado, how often was that tornado? So maybe they're watching, I don't know. So warm advection over us. So it looks like a nice day. Let's just take a quick peek to see what the forecast temperature for Monday afternoon is going to be. We have to go to 2-meter temperature. Yeah, this is just, especially from model output, but upper 60s, so not too bad. When we get into Monday afternoon. All right, so quick back to the precipitation rate. Let's go to 96 hours. I'll just step forward quickly. Yeah, probably our dew point is increasing a little bit, but still 564 thickness contour to our southwest, so warm advection continuing, breezy conditions. Monday night into Tuesday, not going to be too chilly. I'd imagine with a brisk southwest wind.
First warm night of the year.
Yeah. And just for quicks, go to the 2-meter temperature Monday morning. It was a mid-40s. No, actually, well, that's
Yeah, it could be 55, huh?
I guess what's wrong winds? That would be. It brings dew points up, or they've come up considerably. Yeah.
Oh, yeah.
So, wow, look at that. Bring the cursor over this. Just
Foggy Tuesday morning, but warm.
It's one of those days that you would wake and leave the windows open.
I know.
55.
That's nice.
We're saying, when it first warms up, you're 10 degrees off. I was my mid-40s. That explains that. And also look at this tongue. This is, again, with that anticyclone that's now being targeted off the southeast coast of the United States, the so-called return flow around it. Again, this is the beginning of this moistening up of the Gulf area, the Gulf Coast area, and then the surge of moisture northward. I've seen this many times. This is just the interesting thing, how these highs begin to sort of set up and then begin to maintain themselves as you get convection or heavy precipitation rather that lowers the PV in this region. Keeps it sort of self-fulfilling.
But this is a tropical plume that goes all the way up to 10 to 12 kilometers above the ground. It's not just
This
that
is
surface
right.
high.
Mhm.
It goes up very deep, and there's very low potential vorticity booming up into the Midwest at this point at a high level.
We can take a look at that. But let's go back to the surface and we'll go ahead let's go to 120 hours. Ideally, those high dew points, we're still not getting much in the way of precip because you need some mechanism to lift or you need to get some instability developing. I guess this might be perhaps, but we can look at that. But again, along the periphery of this, you can now begin to see with this front that begins to form as the cold advection occurs, light precipitation beginning to form right ahead of the front. This will be probably Wednesday morning is when this is expected to pass through our area. Again, this broad anticyclone that Craig suggests extends much deeper than just a surface on the tropical ridge. It again sort of remains anchored in place. We'll see precipitation beginning, amounts, totals beginning to really increase since this is fixed in knowledge. 120 is got 144.
Ooh, yeah.
So now beginning to light up a little bit with heavier precipitation again on the periphery of this broad anticyclone. Not much occurring in the southeast, but everything on the edge of this kind of reactions.
That's what I call a cool rumble. It'll be cool, but it'll be rumbling from the south. Maybe.
With gray skies kind of.
Yeah, right,
Murky
exactly.
day.
Yep.
And finally, got 168 hours, and we'll just stop there. So for next week, our last weather watch for the season, unless we got something really exciting happening, another snowstorm perhaps before the next semester. I think we'll have a weather watch for that.
Yeah, we would.
Okay.
Yeah.
But we'll have many because of the tropical cyclone. Will be so frequent.
Yeah, there might be as many as 10. Wow, that's exciting. 10 storms. Wow.
One a week. No, but again, by the time we get to Friday of next week, it looks like been a quiet week, really. I mean, this weather precipitation as the front goes through, and then depending on how far south it goes and progresses, we might still be but get a very quiet week. If we look at the total accumulated precipitation over this 168-hour period, and you can see it's ringed around the area of the broad anticyclone. A little bit of this is from what goes through over the next day or the next 24 hours or so. Again, this is not a too bad a week. If we go to the entire end of the forecast period, it's 84 hours. And you really get a sense that this ridge is going to be the focus of precipitation. Still relatively dry. That's something we have to watch in terms of just for farming interest, but again, significant precip to the south. But this week actually doesn't look too active convective wise. I don't know if it's where were you expecting? What day?
More in the middle of the week next week.
More in the middle.
They'll probably be a threat somewhere Monday, Tuesday, Wednesday, finish that. Wednesday looks.
Let's look at 120 again. Here's what we have in
It's like the most widespread.
Tuesday, yes, Wednesday. And so perhaps I'm here. Let's go to 0 right along the front perhaps, or just south of it. Maybe Wednesday.
Potentially along a dry line. It's set up somewhere in Texas, Oklahoma, Kansas.
It's a good input.
Oh, look at that.
That's a dry line.
Yeah, it may not be widespread. It's not, it doesn't seem like it's a ton of forcing. So maybe isolated effect on, especially Monday and Tuesday.
Also down in south, far south.
Yeah, I'm not sure how far south, but yeah, certainly along the front in Iowa and Alaska, there'll be a nocturnal convection potentially.
Okay. And that's earlier in the week. You're looking at for the 96 hours. Tuesday, 12 D, and looks like a little low of the jet overnight, perhaps. Monday and Tuesday.
Potentially, yeah. Tuesday, Wednesday, Thursday. It seems like there's a couple waves coming out, so the timing of those is actually that's not really keep it like it down between the waves.
Not widespread convection, but perhaps some isolated events in the middle of the week. But I think the other big features that again, this extensive area of precipitation that sets up on the northern periphery of the ridge as it continues to develop to the southeast. I guess finally, since we're here,
Well, let me point, I think mainly from what I can see, it looks like Thursday evening. I'll look at that.
1:38. What's 2 days? Thursday evening over where, right?
Well, over the southeast. But, they're showing something on there. What's happening is that whole region over the southeast has very low potential vorticity, a lot near zero.
Wait, you say southeast, you mean? No.
Just the whole southeast in there, yeah. And
That's
then
probably
the border is where you're gonna see more activity. But there's kind of like a atmospheric river over there coming up through Texas.
Okay.
So if you look at the precipitable water, you probably see it. Yeah. You can see that.
Right.
Connects right up down with the Tropic Plus. That's that.
And look at this, you can also see a train just south of the anti-cyclone, right next to the water, from the Caribbean.
And it's coming right up. So I don't know. I'm saying that the tropical part of this picture is there. I don't know if we have any dynamics.
Right.
And if we do have dynamics, that's a pretty good situation.
And the main, still, by my eyes, like the main event will be sort of stratiform creeks along the boundary that front.
Yeah,
creeks.
at this point.
But yeah, we'll see how things change. Anyway, well, thank you, Pete. Thank you, John, for the observation discussion and everyone being here and the contributing to the discussion. See you next week.